Welcome to a further episode of In the Beginning, Investigating Genesis. Today we will be looking at Genesis 1, day 4. And in Genesis 1 from 14 to 19 we read, "And God said, Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and for years, and let them be lights in the expanse of the heavens to give light upon the earth." And it was so. And we can see here already, and that's why I've got the pictures here, there are unique characteristics on this earth. It is rotating on an axis that is inclined by 23.5 degrees. And it is that gives us seasons. And it is very important, as we will see a little later. But it's not just a coincidence that we have this axis. In verse 16 we read, "And God made the two great lights, the greater light to rule the day and the lesser light to rule the night." And then almost as an afterthought, "and the stars also." Just think of that. The galaxies, the stars, the Milky Way, everything, and the stars also. "And God set them in the expanse of the heavens to give light on the earth, to rule over the day, and over the night, to separate the light from the darkness. And God saw that it was good." So we've got the sun here, which is an enormous star, not extremely big. It's only about a typical star of 10% of the stars that you get. But just in this picture here, the comparison of the earth compared to the sun, and then the moon compared to the earth. And that is all converted to energy, and that is the light that we have and the heat that we get. "But God set them in the heavens to give light on the earth to rule the day, and the moon to rule, to be the smaller light, to rule over the night. And there was evening and there was morning, a fourth day," we read in verse 19. And just to illustrate that here, I got a picture here of Google, where we can see the earth rotating around the sun. The sun itself is rotating once every 27 days, the earth once every 24 hours. The moon goes around the earth once every 28 days. And the earth goes around the sun every 365 days. Now, these days here are not 100% correct in the sense of hours and seconds. There is a slight difference from year to year, and but this is the sort of general picture. Now consider the contrast. Remember, we've just touched a very, very tiny aspect of astronomy here and how the earth and the moon and the sun works together. But notice in Genesis 1, we see in the first 13 verses from day 1 to 3 that God creates time. And you will recall from earlier investigating Genesis episodes that God is outside time. He created time, He created space, He created material in all its detail. We're talking protons, neutrons, all the particles, the subatomic particles, and the energy even that is available in this universe. And He did it by His word. And God clearly announces His identity and His ownership right in the first verses. And I put their ownership because if He is God and He designed it and made it, He created it, then He's also the owner. And God takes the first couple of verses to develop order by separating chaos. And God prepares the food factories, in other words, created the vegetation for living creatures. So I just highlighted that here and said, God separates light from darkness, which is part of separating chaos. He also separates the waters above the heavens from the waters on earth and under the land. And God separates the land from the seas, and He made the distinction between plants and herbs and trees bearing fruit according to their kinds. And remember that word kinds. It'll appear a couple of times in Genesis. So what is God doing on this day 4 and 5 and 6? Well, with my engineering background, I would say he sorted out the bigger picture, and now he's doing detailed design and development on the stage of the universe in preparation for animals and living things generally, and finally people. Now, let's have a look at how the heavenly or the Genesis side looks and the earthly side, the science side. And I've put it like this. On the left here, we've got nature. And nature as it is, even if you're not a believer, for the moment, just say it was created by God. Why? Well, he says so. And we read it in Genesis 1. And I just want to take you back to that very, very first verse that we had. In the beginning, God, Elohim, created the heavens and the earth. And you know, Hebrew is so descriptive. And he simply says so, and it was. But it's nature. And nature exists. And nature is discoverable by the humans that are still coming. What I mean here is that nature exists and its laws are clear, and we have the intellect to discover what this universe or nature per se is all about. In substance, though, nature is prescriptive and it is non-negotiable. It is there, like it or not. You don't like gravity? That's tough luck. You don't like electricity because of magnetic fields or whatnot, a bias you might have. It's not negotiable. It is there, okay, in substance. The laws that govern nature cannot be violated by man without reaping consequences. And they can be very serious, and they are immediate. If you think of gravity, if you think of electricity that's coming out of the plug in the wall, these laws are also, and nature is very structured, and there is order. If you just look at the mathematics, the physics, the chemistry, and the information behind it all, there is order in that natural world. It is very consistent. It is always valid. You might say, well, what about miracles? That's a separate story altogether, but I just want to say so much right now, and that is the God who created nature and all its laws can at any time intervene and change something, and change wine into water, or have a virgin conceive a child, or let the sun stand still. And there are such episodes described in Scripture. It is also assumed, but we've never ever found that it is not so far, that these laws are valid everywhere in the universe, as far as we could see so far. And evidently, these laws of nature have to be sustained. I mean, gravity is always there. It never sleeps. You know, you've got to sustain it. If we would not have gravity constantly there, the Earth would fall apart. You would fly into outer space. That's not going to work very well for you or for me. We also see that this whole Earth is, in hindsight now, because we are way beyond Genesis 1, because we're living in 2020 after Christ. So an ecologically interdependent system is what we find in nature. It's interdependent. It's extremely interdependent. And that is what all the trouble is with if species die out and so on, or mankind is doing things they shouldn't be doing because they're interfering in the interdependent system that is ecologically very well balanced. But that's another topic altogether. In fact, each one of these bullet points is a separate topic. But what is amazing is how beautiful it all is, how awesome, how indescribable, and that it actually works. But it is my point here that all this is prescriptive. That's not something that man thinks up. It is something that is there. But when we look to the other side, the science side, science simply means knowledge, then human methodology and perspective comes into the picture. Humans have the habit of having bias, of having a certain pair of glasses, if I can put it like that, and they will look at what they see in nature and then work out a methodology, right or wrong, and make certain conclusions, draw certain conclusions. And this methodology is really based on observations in nature. It is based on certain assumptions. That is always so. There's nothing wrong with that, except when you see later that as you proceed and you want to discover the theory behind something, then you might have to change your assumptions, because assumptions are exactly what it says, assumptions. That may not be the truth. So human methodology, modern scientific experimentation should be based on formulating a hypothesis, formulating a theory, doing certain experiments and validate that theory. If it works, it works. But science has decided that it will be exclusively materialistic. What that means is everything has to be based on the materials that we find in the universe and random principles. Now, maths and physics and chemistry all contains information. And information is usually something that has to be interpreted with intelligence. It's probably put there by intelligence. And a sort of a very easy comparison here is if you pick up a book and it is in English and it has a lot of print in it, a lot of words and text and so on, then that is information. And you would not assume that a bottle of ink fell over that book and the ink then arranged itself into that text. It just wouldn't happen. But if we want to discover something scientifically, and we discover a book and we've never seen a book before, and you want to draw a conclusion, you make assumptions, you might come up with a conclusion which is total nonsense, because you deny that there was an intelligence involved in getting the text onto the pages. You get the drift. There's a philosophical perspective in science, because it depends a lot on your own philosophical perspective that you go into developing a hypothesis and a theory for a phenomena that you want to investigate. And there's then this bias, and we're all biased. Bias in paradigm, in the interpretation of the facts, and how we present the facts. Just look at experimental results from the pharmaceutical industry that is often interpreted in a particular way, and the facts are presented in a particular way of graphs, and there is a lot of cheating going on, believe it or not, in science. Theories and paradigms change often, and there is nothing wrong with that, except because as new information becomes available or new insights, you can change your theories. But the paradigms should also change if you are, let's say, a flat earther and you find out that the satellites and everything that has to do with the space program shows that the Earth is actually a sphere, then surely that paradigm is no longer valid. And you must change it. That's an extreme example. Why do we believe scientists? Well, usually scientists are such experts in their fields that you can hardly argue with them if you as a layperson or somebody who is not on par to that degree with that particular aspect of science or discipline, that you can actually convince them of anything because you know so little. And I am not an expert in all the sciences either, but I personally operated in operational science, in other words, hard science of maths and physics and chemistry and information for many decades. And so I know where the pitfalls are and what can be done and what can't be done. And if I were to have a discussion with somebody who knows nothing about that, I can probably convince them of a theory of mine where I even know it is wrong. I could do that. So we believe scientists because we think the people in the white coats know better than we do. Nothing wrong with that if they're honest. Can a scientist be wrong? For sure they can. And then we discover it with all the spacecraft that we are sending out to the various planets. And I have yet to see a report of the first time such a robot flies out there to, let's say, Pluto, and it discovers things that none of the astronomers had assumed would be there. It is absolutely amazing. Now again, how would they know? They haven't been there before, so now it's a discovery. But the emphasis that scientists who have not yet been there in a non-operational science, they are very, very forceful, and they say, this is how it is, and that is just not true, because you cannot repeat the experiment and you haven't been there. And that goes for many things. We will see later, star formation, galaxy formation, black hole formation. Nobody knows if that is actually true and how it worked. There are theories, not theories. There are ideas around it. There are possibilities, but it cannot be proven easily. And mathematics even has its limits when it comes to proving something that you cannot experiment on. But that's a long story. It's a separate day for that. So what do people interpret as scientific? Well, people interpret things that are operationally scientific, and that is how we get cell phones and motor cars and rockets flying to the International Space Station. There is science behind that. But guessing the age of a particular planet, or how a particular system formed, like the solar system, those are guesses. But the layperson doesn't know that. The layperson assumes that if a scientist says the sun is so many billions of years old, that is the truth. And that is not true. That is, in fact, is conjecture. There may be good reasons for that conjecture, but strictly speaking, it has never been proven. It is assumed, and that is used as the basis of how old is the Earth, how old is Mars, how old is Pluto. And we see all sorts of anomalies if we go deep into that. So there is this big difference between operational science and historical science. And archaeology and paleontology, those are all historical sciences, because you find some fossils and you have to draw certain conclusions. But you're doing it not on the basis of repeating the past. You're doing it on what you see there. It is forensic science to a point, but there's a lot of guesswork in there too, because the paradigm already says it must be millions of years old. So we are looking for evidence that tells us this is 1 million years old. I'm not very on par with geology, but I've read a lot of articles, learned articles, and books on textbooks on geology. And since I'm interested in that for the last 10 years or maybe 12 years, I have noted that journal papers and so on are making the creation of the Grand Canyon in the United States younger and younger. The first time I read something, it was something like 500 million years old, then it was 50 million years old, then it was 1 million years old, and now we're at about 500,000 years old figures. So what is the truth here? But that's historical science. And it is unfair to compare historical science with operational science, but historical science is treated by laypersons and historical scientists in the same way. And that is not correct. But my whole point of this slide is that nature is prescriptive. It is there. It is what it is, like it or not. And science is trying to figure out why it is like that and it's descriptive. It describes what we see out there in terms of maths and physics and chemistry and information. And then we draw conclusions. Now, this prescriptive and descriptive is actually very subtle. You see, for every effect we observe in the universe, we imply that there is a cause that resulted in the observed effect or effects. So every effect has a cause. And that's, of course, always the ultimate argument of an atheist when they say, well, who caused God? Well, God is not a cause. God does not need a cause. God is. He made all the rest here. He made everything and caused it in Genesis 1. If nature is prescriptive, somebody, a person, an entity must have prescribed it. This requires knowledge, it requires intelligence, it requires information. And the laws of physics in the broadest sense are a given. And they are prescriptive. That's how they are. It was up to scientists like Newton to discover what they could be. And he formulated it, and he formulated it in such a smart way that we have never seen a case where it isn't valid. Okay, we're not talking now about relativity and all that stuff. That is too heavy for a course on Genesis. But an example would be of prescriptive physics, gravity, electromagnetic fields, thermodynamics, optics, fluid and gas dynamics, stress and strain in materials and vibration, and even mathematics. Mathematics is not man-made, because mathematics and physics, in other words, physics that is prescriptive, are almost one-to-one. You can explain almost everything in physics with mathematics. And that means if there is such a one-to-one correlation, that mathematics is closer related to physics than it is to man's ingenuity. We can handle these things, yes. Now, science can often describe things, and yet not know things. It can describe it, but not know it. We have ideas about it, yes, that's okay. But what comes after that, without experimentation and proof and repeating the situation, it's conjecture or speculation. We can hypothesize. You know, when I think back of some of the most interesting books I read, a book of about, I can't remember, 400 or 500 pages on emptiness and nothing. Why would that even be a book? It's highly scientific, because human beings and scientists in general, or specifically, have struggled with the concept of what does empty really mean. Because even if you describe something that is empty, that in itself is not empty. So a nothing is also not nothing. Long story behind it, we're not going to go there. Energy is another one of those things. We all know, in a way, what energy is. We know that coffee gets cold and that energy is required to move the pistons in your motor car. But exactly, specifically what energy is, we can express it as a formula, but it's very, very difficult. Light is one of those, because light can have the model could be that there are particles of light, like photons, or that it is really a wave. And it's a sort of a both. It's a parallelism, but that actually means we don't know exactly what it is. We describe it sometimes as waves, sometimes we describe it as particles. And even the formation of planets and stars, as I've already explained, you know that if you speak to astronomers of repute, they will admit, and I've got quotes somewhere, that nobody knows exactly, because the nebula theory doesn't really work. Operational science is the process to formulate these laws of physics, as I mentioned, through observation, hypothesis, experimentation, validation. You want to show that it is always like that, and developing this process into a theory, which is then stated as law if we observe that this law is always observed. Then the theory is probably correct. However, if this theory is just falsified once, then it is no longer a valid theory. In fact, it cannot even be seen as a valid law, or possibly even as a valid theory. And there is no doubt, science is ultimately descriptive of nature in very sophisticated ways, but always within a certain paradigm or worldview and assumptions and conjecture. Make a mental note for the rest of Genesis 1 that many current scientific paradigms and hypotheses are seriously erroneous or in doubt by different top experts in their respective fields, especially in terms of origin, deep time, millions and billions of years, and surprisingly also often in terms of the scientific process that was employed. Assumptions have to be made, but they also have to be changed when new evidence arises. And you see, some theories are so dear to the scientists that they don't want to let go. And evolution is one of those, but more about that later. Now, modern discoveries in diverse fields of operational science make a framework for a created world by a creator more and more reasonable. Because if you look operationally at the fit of maths and physics, of the way this universe is put together and seems to work perfectly well, especially when you get to quantum physics and cosmology, what is being discovered there mathematically is absolutely mind-boggling. The fact that this universe even exists and is reasonably stable is mind-boggling. But again, that's a deep, deep story which we're not going to handle here. But my point is that operational science makes it more and more reasonable and rational and convincing that there is a creator behind all that. The rich underpinning of inherent information and structure and order in a so-called random universe inevitably forces us to the conclusion of purposeful design in nature. And some current scientific models are based on a preferred philosophy rather than a traditional scientific process. So the preferred philosophy takes precedence over traditional scientific process. We need to look at the bigger picture in a systems thinking context, and that all starts with our worldview and perspective, like glasses that we have on. When we have that worldview sorted out, then we can do our science, and then we know where we stand. Now, let's get a little bit closer. You can see we're talking Genesis, but I'm trying to build a bridge here between the science of what we observe and see and so on. Because we live on a planet that is itself rotating at quite a speed. It is also going around the sun at quite a speed, and the sun is moving in the galaxy at quite a speed. So velocities are always with reference to some framework. If we say we are traveling in a car at 60 kilometers an hour or 60 miles an hour, or stopping, that is relative to what? The relative is probably relative to the ground we are traveling over, because nothing else would make sense. If I said my car has stopped at the stop street and I want to use the reference of with respect to the sun, then I've got to add the Earth's rotational velocity and the Earth velocity in the orbit around the sun as well. Nobody does that, of course. And you can see it very clearly also when a spacecraft is docking at the International Space Station. I don't know if you've ever seen that. These two vehicles, the International Space Station, the ISS, and the spacecraft, are both traveling round about 28,000 kilometers an hour. And it looks as if they're moving at each other at millimeters or centimeters at best per minute. So the speed is always relative. And GPS references are also very, very important. And our GPS reference in the car is relative to the car. But you know that the satellites themselves up there in geostationary stationary orbit, they have to be adjusted in terms of clock time continuously, because they differ from each other and from the people on the ground. And when we look at the planetary side and the solar system and the galaxy, I just want to quickly show you, our Earth is running at about 30 kilometers a second. Hello? 30 kilometers a second along its orbit around the sun. The solar system itself is running at 230 kilometers a second in its orbit, and the Milky Way galaxy, of which we are a part, is itself rotating at 600 kilometers a second. We're not talking kilometers per hour here, we're talking kilometers a second. And if you put that into a sort of a video format, this is an animation obviously, you see the sun rushing along at 230 kilometers a second, and all the planets going around it and being sort of dragged along by the gravity of the sun. And the sun itself is then still dragged around by the Milky Way galaxy at 600 kilometers a second. Those are enormous things. And I also want to point out to you that, the Earth is uniquely made for life. The amount of gravity that we have, the size of the Earth, the tilt that we have for the seasons, the near circular orbit that we have, even the position in the distance from the sun is in the habitable zone. The atmosphere, the composition of 21% oxygen, 78 nitrogen, is just ideal, because if it was much more, everything would spontaneously ignite. If it is much less, you and I would die. The thickness of this atmosphere between 16 kilometers, where we can still breathe more or less, even with aid, and 480 kilometers where there is nothing anymore in terms of atmosphere. And even the transparency of the atmosphere, the light transmission, very important. And then there's this aspect that we are a water planet, and we have liquid water, lots of liquid water on it. And also the fact that ice is lighter than water, because if ice would be heavier than water, it would sink to the bottom of the ocean and freeze up the ocean in a few years completely. The characteristics of water are absolutely amazing. It is an ideal solvent, it has high specific heat, and there are many, many other characteristics of water that are essential for biological processes to work, including your own body. And tectonics and volcanoes. And the thickness of the crust of this planet is just right. And we have the magnetic field and the Van Allen belt. We could carry on and on and on. But one of the amazing things is the large moon that we have relative to the Earth. It keeps rotational stability of this planet. That's how we keep our temperature even. We live in a very, very small temperature window really on this planet if you compare it to the outer space. And the moon makes for observable perfect solar eclipses. And that is our human first window into the solar system. And we learned a lot of things from that. And that happens because the moon happens to be about 400 times smaller than the sun, but the sun happens to be about 400 times further from the Earth than the moon is. And what then happens occasionally, but it is predictable, is that the apparent disk of the moon is almost the exact size of the sun. And if you're standing in a total solar eclipse on the Earth and you're looking towards the sun, you can see the outer fringes of the sun and make your first deductions of what the sun consists of, what the temperatures are on the sun, and so on. And it is almost perfectly, ideally made for us. Is it a coincidence? I don't think so, but it might be, but I don't think so. Because there are so many other factors, We have an ideal sun in levels of energy, intensity, and stability, and only 10% of all the suns we have observed out there due to astronomy or astronomy science, only 10% of suns actually fall into this category. And our sun is a very young sun. And there's a bit of a paradox in that, because we shouldn't have a stable young sun. We are also very fortunate that our sun is not a blue giant sun or a red dwarf sun. On the one hand, you would have too much ultraviolet, and we would lock the planet, and with infrared, photosynthesis will also not work. The Earth is at the right distance away from the Sun in the so-called Goldilocks zone, and with large planets like Jupiter, Saturn, plus Uranus and Neptune acting as vacuum cleaners for space debris like meteors, we are essentially very, very fortunate to have that. Because if we did not have that, we would be bombarded and our face of the Earth would look a little bit like the Moon, except with all the water, of course. It would not be so visible except on land. Is it a solar system made for us? Well, here's another interesting point. We are in between two arms in the Milky Way. So that's where we are. We are on the edge of a spiral arm. We're nowhere near the galactic center, which would be full of radiation and all sorts of trouble for us. There's also almost no space dust in the position we are in. So we have clear all-round vision. That's important. Because if we looked in the direction of the arrow, in direction B, we would look at that center of the galaxy, and that's what we typically see in that picture called B, all right? We're looking in the direction of the center of the Milky Way. If we look in the direction of A, either way, up or down, relative to this picture, then we would see clear stars, and we can have a look with the telescopes that we have. But the center would be an extremely dangerous place. So is the universe made for us? Well, so far Genesis has shown us that the universe had a cause, and that was Elohim. Seeing that it had a beginning and was created by God for a purpose, we can maybe find out what that purpose is. We now find scientifically that the universe is extremely fine-tuned. The universe has over 120 precise physical constants that make it uniquely habitable for us humans here on this planet. The Earth's position, the composition of it, and the size is also fine-tuned. There is evidence for information, for systems thinking, for structure and balance and purpose and structure. And it is obvious for anyone who is thinking that there was mind before there was matter. A, because God created it and He said so, and He is a mind, and there was no matter before that. A mind was there before matter. The beginning, the creation of matter, energy, space, and time also determined the laws of physics. There was no physics before the beginning. So the singularity theory is a very, very, very dicey one, because there's no proof of that at all. And that actually means that in that singularity, you have to pack everything the universe has to be in that one single point called a singularity. But that's a figment of the mathematical imagination of scientists that want to prove a point there. But you cannot prove a point that doesn't exist, because nobody's ever seen a singularity like that. The Earth's position and the specifications that we've now described so far are now ready for fish and birds and mammals and humans. And now it's going to get interesting. I'm just putting all this into Genesis 1 for the simple reason God, from a systems perspective, got all the preparations right to now start with living beings, creating fish and birds and mammals and humans. And well, Scripture says the following: the heavens declare the glory of God, and the sky above declares His handiwork. There's no doubt about that. Day to day pours out speech, and night to night reveals knowledge. It's absolutely amazing. And in 1 Corinthians 15 we read, there are heavenly bodies and earthly bodies, but the glory of the heavenly is of one kind, and the glory of the earthly is of another. There is one glory of the sun, and another glory of the moon, and another glory of the stars. For the stars differ from star in their glory. And look at these pictures. You've seen many of the Hubble pictures today. They are absolutely amazing. But in Isaiah it also says, "For thus says the Lord who created the heavens and who formed the earth and made it, I am the Lord, there is no other." Repeated also in John 14:6, when Jesus says, "I'm the way and the truth and the life, and no one comes to the Father except through me." What do you do with a sentence like that if you're an atheist or a believer in something else? What do you do? So, what do we know? Very clearly, there was a beginning, there will be an end. We haven't gotten there, but there will be an end. There's purpose, but it's God's purpose. Then sin crept in. There was a fall, and entropy started. Everything got more disorganized and corrupt, and entropy is all around us. The battle for you and me is in full progress, daily. And God, by His grace, through Jesus Christ, has saved those who are willing to believe in God and Jesus Christ and be open to His working of His Spirit in you. You think this world is great, and if you're a positive person and you walk into nature and you look at the details, yeah, this world is great, but God's heaven is something so wonderful, you and I cannot even imagine it. It'll be even more fantastic. So I want to thank you for listening to all this. I just wanted to build a bridge between Genesis and scientific endeavor at the stage of Genesis where we are at the moment. So I want to leave you with this last quote here, Romans 1:20, and this is also something we should all think of. "For since the creation of the world, God's invisible qualities, His eternal power, His divine nature, have been clearly seen." It's obvious to everybody, right? "Being understood from what has been made." So here comes the clinger. "So that men are without excuse." You see all this? I'm always amazed that people can believe that this just happened randomly, and it is so perfectly balanced and so finely tuned that that is just coincidence. And there isn't another planet in this solar system or anything that we have already found, even exoplanets that are anything like the Earth. Thank you.